Okay, so we're looking at measures of dispersion today. We talked about how to enter data, even ones that have frequency, into our calculator. Our calculator can calculate the mean, the quartiles, the median. We can do a box plot with that. We can do a histogram. I left that histogram one for you guys to do, but we're going to do it today, so it kind of covers that. You don't really do it that often, but we are going to do that today. Okay, so it says, let's take a look at the first part. It says, although a measure of central tendency is valuable, this is not the only important statistic. A measure of the dispersion or spread of the data is also important. Examine the frequency tables below that summarize the marks on test 1 and test 2. So take a look at them. Remember, these are frequencies. Okay, so this means 9 people got a mark of 9. Maybe it was out of 15, 9 out of 15. 3 people got a mark of 10. 7 people got a mark of 11, and so on. Okay, so then it says use the stat function on the graphing calculator to find the mean. So not by hand. So get out your calculator and clear that. Go to Stat, Edit, clear off your old list. So up to L1, clear, not delete. And then in the first column, always put the data values, the marks in this case. So 9, 10, 11, 12, 13, 14, 15. Okay, cursor to the right, and then 4, 3, 7, 8, 6, 5, 3. Okay. Now, what I'm going to do is I'm going to put all of these in. Okay. Now, take a look at test number 2. The data values are all the same. So your calculator is kind of nice. You can save yourself some work. So for test number 2, L1 are all the data values. So for frequency for test 2, I'm going to put those into L3. So I'm not going to redo the marks. Okay, and then that's 1, 1, 8, 18. So 1, 1, 8, 18, 7, 0, and 1. Okay. Okay, so now it says use the stat function to find the mean of each set. So if we quit out of this, then we go stat, calculate, one variable. Now think about test number 1. The marks were in L1, but the frequency was in L2. So then you go second 2 to get L2. If you don't do that, it's going to calculate the mean of 9, 10, 11, 12, 13, 14, 15. Okay, so you have to put the frequencies in there. And then enter or calculate depending on your version. Okay, so the mean is 12. So I'm just going to here. Okay, so you can use mu. Actually, no, I'm going to use x with a bar, because that's what your calculator says. Okay, so that's for test 1. And then test 2. Now, we saved ourselves a little bit of time because we didn't have to do 4 columns. We did 3. So you can clear that out and then go stat, calc, one variable stats, but then our frequency, remember, is in L3. Still, you have the same list in L1, the data values, but now that's in L3. Okay, and that's 11 point, it doesn't say what to round to. We'll go 2 decimal places. 11.92. Okay, so pretty close, right? Then it says use the graphing calculator to draw the histogram, and it gives you a hint on the window. As I said, we don't really do this that much, but we've given you a hint, so let's take a look. It's good to use today to analyze these two sets of data. So change your window to 8.5 to 15.5, so just a little bit below and above the data values that we entered. Then y-min -1 to 19. Again, the biggest is a frequency of 18, so a little bit above that. And we'll do scale of 2. Scale doesn't really matter. Okay, and then we have to tell the calculator to do a histogram. So remember, that's a stat plot. So second y equals, so we probably already have a box and whisker entered in there. So it's still on, or mine is still on, yours probably is too. And so cursor to that histogram, that bar graph looking, and enter on it. Okay, then tell the calculator, are your X values in list 1? Yep, most often they are. The frequencies though, there's not one of each. We're doing the frequency of that are given, so that's in L2, so second 2. Okay, and it's going to do mine in blue, so I'm going to just press graph. This would be for test 1. Okay, so not too, not too variable, a little bit more in the middle, kind of makes sense. Let's take a look. I'm going to graph another one. Now, if you don't have a color version, which a lot of you won't, then just do it separately. So a lot of you will go here and just change this to L1 and L3. I'm actually going to graph over top of it so we can see it a little bit, the differences. So I'm going to turn my second one on and enter on the histogram, and then L1 and now L3. So that's second 3. And now if I press graph, it's going to graph it over top, right? So I can kind of see the difference. If you don't have a colored one, then it'll be hard to see the difference, right? So this has definitely has more in the middle, getting a score of 12, right? And then nothing for 14 and ones at the edges, right? So same number of people writing the test in each, but they're more concentrated in the middle. Okay, so they're not as spread out. The first test, they were more spread out. This one, there are fewer people with marks at the extremes. Okay, so that's something to be aware of from comparing histograms. So the means of the two sets are relatively close, but it is apparent that the marks for test 1 are widely dispersed, whereas the marks for test 2 are concentrated. Having a small spread or dispersion may not be desirable, as it does not differentiate between the abilities of the students. Okay. In contrast, manufacturers of precision instruments want a small spread on the dimension of the items they produce. They don't want big differences, right? Either way, it's important to have a way of calculating a numerical measure of the spread or dispersion of the data. The most commonly used measure is the range, and you've done that before. You just take the highest and subtract the lowest. Okay, so it's basically the difference between the extremes. Standard deviation is a measure that indicates how the values differ from the mean. Okay, so that's what we'll really be looking at today. And interquartile range, we did that. That's sort of looking more at the values, the middle 50% of the values. Okay, so question 3, determine the range. So this we can just look at right away to get the range. So here, I'm going to circle the largest, which is 81, and the smallest is 56. So 81 minus 56 is what? 21, 25. Okay, so that's the range of the data. Again, doesn't really tell us a whole lot. They could be, one could be 56 and the rest could be 81, knowing this range. Okay, so question 4, determine the variance and standard deviation of the following. Complete the table to calculate. Now, we're going to complete the table today, but really from now on in, after this, you're going to use your calculator. You might, okay, so question here, sorry, before I go on. Couldn't a red line just be behind the blue one? Well, if you graphed it separately, Jaden, you would be able to tell that, so if you graph this separately, there will be nothing there, right? I just happen to graph them together. Okay. All right, so in science, if you haven't talked about standard deviation and variance already, you probably will. I don't think they might make you do some by hand. I'm not really sure, but it's a good idea to do it one time and then use your calculator. So that's what we're doing. So determine the variance and standard deviation of the following data. Complete the table. So determine the mean. All right, so this data is 12, 14, etc. So you can add all those up and divide by however many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so notice it's not a frequency chart because there's 2 18s. All right, so just add them up. Probably do it faster than I can on the screen. Okay, I think I did that okay. And then divide by 10 is 18. Okay, and then it says determine the deviations from the mean. So basically you take 12 and subtract the mean. So 12 minus 18 is negative 6. 12 minus 14 is negative 2. 12 minus, what did I just do? 12 minus 18 is negative 6. 14, I don't know what I'm doing. 14 minus 18 is negative 4. 16 minus 18 is negative 2. Negative 1, 0, 0. Positive, 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 positive. Okay. And then square each of those. And then add those up and find the sum of those. So 36 plus 16 plus 4 plus 1 plus 1 plus 4 plus 9 plus 49. Okay, so that's 120. And then it says determine the square of the deviation. So we've done that. Determine the mean of the square deviations. So that's 120 divide by 10 of them, right? So that's going to be 12. and that's called the variance. Okay, and it's often denoted, that symbol here is a lowercase sigma squared. S squared is for a sample. Either one of these, really we end up using this sigma more often, and that's what your calculator has as well. That's what we're going to look at. Standard deviation is the square root of the variance. So this is the variance here. Okay, so this is sigma squared, and so the square root of that is root 12, which is 2 root 3. Often we go to decimals. So what is 2 root 3? 3 point, we'll go to 2 decimal places, 3.46. Okay. So this is the formula that we just did. Okay, now that you know sigma notation, you're taking for each, actually there should be a lowercase I in there. It's down in the version here, okay, but I just realized that it's missing there. Yeah, we're going to talk about that in a sec, right? So just bear with me. We're just doing the calculations for right now. So this tells you, will help compare different sets of data. It really doesn't tell you a whole lot right now, but once you compare sets of data that represent a test or the same situation, then you'll look and compare the standard deviations, and that will help tell you the dispersion. We'll learn more about this as an actual value when we look at a particular distribution of data called a normal distribution. That'll be in, I don't know, a week or two. Okay, so as you can see from this process, the standard deviation gives a measure as to how far the values deviate from the mean. A small standard deviation indicates that most values are close to the mean, and a large indicates that they're widely dispersed. So as I just said, it depends on the data though. You look and compare. So the smaller of the standard deviations of two sets of data means that smaller one, that data is not as spread out. So you use it as a comparative. So there's the formula if we had a frequency chart. Remember, you'd multiply it by the frequency. You don't really have to worry about these formulas. You will see them again if you continue on to Math HL. We'll look at the formulas in more detail, but really for this course, you're just going to end up using your calculator. Okay, so not a whole lot of more calculations on that. So now it says the stat function on the calculator can be used to determine the standard deviation of ungrouped data. Ungrouped means like one of each. So calculate the standard deviation, and this data here, so 12, 15, 16, 18, sorry, that was actually, no, it's different from the data we just had. So even if you had put it into a list, you got to do a new list. All right, so now when you go to a list, I'm going to give you a hint on this just because I know some of the questions coming up. Go to your stat and edit, okay? But don't clear these because it's going to ask you to go back and look at the standard deviation of those again. So go to L4, okay, and enter the values. So 12, so go over here, 12, 15, 16, 18, 19, 20, 21, 23, 24, and 35. Okay, so I've got 11 entries, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. Okay, So standard deviation, we do the same as when we're calculating the mean. So quit out of that. Okay, go stat, calc, one variable stats. Now I put that list into L4, so I do need to change my list to L4, and my frequency, just delete it, because remember there's just one of each of these. So you just need L4. And calculate. Okay, so there's the mean, etc. We're looking for sigma here, this sigma x. All right, so this rounds to 5.76. All right. So that's a single set of data. Then it says stat function can be used to determine the standard deviation of a group set. Okay, so frequencies. So go to your stat, edit on your lists. Now we don't need L for those question number 5 values again. Okay, so I'm going to go up and clear off those. Or if you don't clear off, you can go to L5. Totally up to you. Actually, I'm going to clear off L4 because we do need 2 lists here, and then it will show on the same screen. So I'm going to clear off that. Okay, so then I go 14, it's faster, 15, 16, 17, and 18. Okay, and then over to L5 for the frequencies. Okay. So going to find the standard deviation. So quit out of that. Stat, calc, enter, one variable, but now they're in L4 because I deleted the previous L4, and my frequencies are in L5. You don't have to worry about SX, Jaden. Okay, it's called the sample, but we're going to use population. So just always look at the sigma. Okay, so here it's 1.18. So that's what you do to find, it's really the same thing, one variable stats. Okay, so then it says, in question 7, find the range of the marks for test 1 and test 2 listed on the first page and compare those values. Well, we talked a little bit about that. So here, lowest was 9, highest was 15 in both of these. So the range was 6. It was the same in both, no matter what the dispersion was. So it's 15 minus 9. Okay, same for both tests. Okay, it says use the stat function on the graphing calculator to find the standard deviation of the marks for test 1 and test 2. So that's why I asked you to keep those lists in. Okay. So I asked you to keep them in to make it easier. Okay, so we're going to go stat, calculate, one variable stats, and then for the first test, that was in L1, and the frequency was in L2. Okay, and we found the mean to be 12. right? And we did that. We did one variable stats. We could have just recorded the standard deviation then, but I didn't. So in this case, it's 1.73. And then do the same for test 2. Okay, remember test 2 is L1 and L3. L1 and L3. Okay, and that's 1.01. Okay, so the second test has a smaller standard deviation. So examine the histograms for test 1 and test 2. Relate the shape of each graph to the size of the standard deviation. So remember, don't bother graphing. I'll just show you my graphs again. So relate the shape to the standard deviation. So the first one with the larger standard deviation was the blue one. Okay, the smaller standard deviation was the red one. Okay, so relate each shape to the size. So the smaller, forgetting where I'm supposed to be writing. The smaller standard deviation gives a graph that is more concentrated in the middle. And this is kind of my joke on this is, graph, it kind of gives you the middle finger. Don't say that to anyone, okay? So it's higher up there and very low on the edges. Okay. Does the range or standard deviation give a better indication for the dispersion? So in this case, the standard deviation does. Okay, standard deviation. I'm just abbreviating a little bit. As the range here is the same for both tests. Okay. So range, standard deviation does, as the range is the same for both tests and thus doesn't show how they are spread out. Okay. So, yeah, so if you have the standard deviation of 2 sets of data, or 3 or whatever, then you can compare them, right? If they're representing something that's similar. If you're given histograms, like in question 10 here, then we can look at it and decide how would their standard deviations compare. We wouldn't know the values, but we could compare them. So 3 histograms are shown, and they all look a little bit different. It says the graph with the largest standard deviation is what? So remember, the bigger the standard deviation, the more spread out the values are. Okay, so which one has values that are more spread out? A. okay? They're all kind of the same, right? Whereas here, there's only a few at the ends and a lot in the middle. Here, a couple at the ends and a lot in the middle, but it's kind of spread out within that. So this would be the largest, okay, standard deviation. This would be the smallest standard deviation, and this would be the middle standard deviation. Okay, so the largest is A, and the smallest would be B. So Jaden, your question said that the range was less reliable overall, though, since you could have one single bad mark and the whole range value would be thrown off. Yeah, that's why it doesn't tell you. Like if you have a bad mark and a whole bunch at the top, and you calculate the range is a very wide number, big number, whereas most of your values are high. So it doesn't give you a good representation. Right? It doesn't show you how it's spread. Okay, so range doesn't really tell you a whole lot. Question 11 says the weights in kilograms of 7 soccer players are given there. Find the mean and standard deviation. So if you want to, you can enter it into a chart, or you can just add them up. Oh, actually, it's standard deviation, so we do have to enter it because we're not going through that whole calculation by hand again. Okay, so I'm going to go back and clear mine because I know that we don't need them. But if you don't want to clear, maybe I'll just do it in L4 and L5. So 79, enter, 64, enter, 59, enter, 71, enter, 68, enter, 74, enter. Okay. Just one list in L4. So stat, calc, variable, L4. Okay, so that's what you need to do for that one. So mean is 69.17. Standard deviation is 6.52. Okay, it says surprisingly, each player's weight had increased by exactly 5 when measured. When measured 3 years later. Find the mean and the standard deviation. Well, let's think about, so here, if I go to that list, okay, well, let's add 5. So that would be 84, 64 plus 5 is 69, 59 plus 5 is 64, 71 plus 5 is 76, 68 plus 5 is 73, and 4 plus 5 is 79. Okay, and so now if I do my calculations on L5, what's happened? I get a mean of 74.17 and a standard deviation of 6.52. So think about these values. They all increase by 5, So that means the mean will increase by 5 because they all increase by a constant value. But by doing that, they're still spread out the same. So adding or subtracting a number, a constant value, to all the data values will change the mean by that amount, but it will not change the spread. So it won't change the standard deviation. So comment on your findings. So the mean will also increase by 5, but the spread does not change. Okay, and the spread is really your standard deviation. Oh, that's a good trick. Brayden, if you go to the main screen, you can put L1 plus 5, and the calculator would tell you the new numbers. That's cool. Yeah. And last one. So this, you're given the weights of 10 turkeys. Really important information. Find the mean and the standard deviation. So same thing. And it says, after being fed a special diet, the weights of the turkeys doubled. Find the new mean and standard deviation. So does that mean the mean is going to double and the standard deviation will stay the same, or what does that mean? So we're going to, let's test it out. So maybe I will. I'm going to go back and clear off L1. And so that's going to be 0.8. What else? 0.9, 0.7, 1, and 1.1. Okay, so 10 values. Just I always check how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Okay, so now mean and standard deviation. And I put that into L1. So mean is 1.01, standard deviation 0.17. Didn't even have to round. Okay, so now, so Jaden, you said that if I'm going to clear off this list. So if I go up here and say L1 times 2, let's see. Yep, there you go. That's fast. Okay, thanks for that trick. So now I want to do mean and standard deviation of L2. Okay. All right, so the mean doubled and the standard deviation doubled. Oops. Oh, what am I doing here? Okay. So, and if you think about the data, if you're doubling, let's say the smallest value is 0.7, so doubled is 1.4. And the biggest value was 1.2, doubled is 2.4. So now that those numerical values are getting further apart from each other. So that's why the standard deviation is now bigger, okay? Because they're spread out more. So the mean will stay the same. The mean will also double. And the standard deviation will double as the values are more spread out now. Okay? All right. So, any last questions on that?